Good morning, everyone. How did the homework go? Get going? And I mean the practice problems. How did the practice problem go? Did you guys do them? You know, they are crucial. The practice problems are absolutely crucial for our work. So I always want you to come and ask me questions about them. Anybody? Okay,
yeah, can you go over
3F? Okay, anybody else? We go through that. 3F, which section, Esmeralda? 1.6, 1.7? 1.6, okay. All right, anybody else?
Can you go over 1.75F?
Okay. I put it on chat, so I will get back to it. Okay.
Okay, thank you.
All right, that will help tremendously. All right, so we start with 1.6 part F, and then we do the other questions. So please put it on chat so I don't lose track of it. So 1.6. So we have the following function. We have f of x. So the goal of this problem is actually, know how to work with function and know how to learn with fraction. So that's really why I'm assigning this problem. So my function f of x equal, so that's the input. For every input x, the output is whatever you input over x minus 6. Okay, that's really what my function is. And last time we did most of the problem and I stopped on f because I asked you basically, I want you to try it to see what you guys can come up with because it's a bit harder. And now the question is f of 3 over y plus 5. Okay, so in this problem, that's the input. It's a mess. That's my input. Okay, and this is going to be equal to what? Right. Whatever the input is, so this is the input, so I'm going to write it, divided by the input. I put it in red to tell you that's the input, minus 6. That's exactly the picture. All right, it's a mess. I know that you can see that. So we're going to kind of do our best to simplify this expression. Okay, so we plugged it in and now simplifies it. Now this is the algebra part. Okay, how do you think I'm going to simplify this expression? What do you think I'm going to do? What is bothering you a lot? What's bothering you? Go ahead.
Would you multiply 3 times y and 3 times 5?
Where? Numerator, denominator?
On the top, the numerator.
Yeah. What do you want me to do here?
Would you get 3y plus 15?
No, you're dividing. Be careful. Yeah, it's 3 divided by this whole quantity. It's divided by it, not multiplied by it. Do you understand? Okay, so we are dividing, not multiplying. So what do you mean by 3y plus 15? Okay, so it's 3 divided by that. So it's not 3 multiplied. So anybody has any other idea? Whatever idea I accept, and we talk about it. Never shy away from wrong answers.
You define the common denominator for 3y plus 5 and minus 6.
In the denominator. So the numerator in this problem, I basically won't touch because it's nice. It's not too complicated. Okay. To be able to simplify this expression, it's this piece that I really would like to deal with it. Okay, that's piece, the denominator. So from here to here, what we're going to do is find a common denominator. Okay, the natural common denominator is the y plus 5. That's the common denominator. So we're going to write this at 3 over y plus 5 minus y plus 5, and this 6 times the y plus 5. Okay. Now, as I said before, so I'm only working with the denominator. So as I said before, we find a common denominator so we can combine the numerator. So now I will have y plus 5 here, that's the common denominator, and here I will have 3 minus 6 times y plus 5. Now at this stage, what I want to do. So I'm almost done if you want. This piece here, we're going to multiply it out. Let's see what this gives me. This is 3 minus 6y minus 30 because I distribute. So this is 3 minus 6y minus 30. Now, it still doesn't look pretty, and we have to make it look as simplified as we can. I haven't touched the numerator yet. The denominator becomes 3 minus 6y minus 30. So if I combine, I will get minus 6y, and 3 minus 30 will give me minus 27. Now, the benefit of doing it this way, I have one fraction divided by only one of them. So it's a fraction divided by another one. So I don't have like before. It was a fraction divided by one, which is not quite one fraction. So that's really what we did. We made this into one fraction, so we have a fraction over another. And now we use the property. Remember how we divide fraction. If you have a fraction a over b divided by c over d, that's the rule, is equal to a over b, you multiply it by the reciprocal. So finally, how I'm going to apply this. The a over b, it means 3 over y plus 5 times the reciprocal of that. So the reciprocal become y plus 5 over this. Okay. Now, this is going to be equal to what? Now, this is 3 times y plus 5, because multiplying means multiply numerator over y plus 5 times minus 6y minus 27. Now, y plus 5 is a factor in the numerator, and it's the same factor. So it's a common factor to the numerator and denominator. It's just like if you have 2 times 3 over 2 times 5, so 2 is a factor here, then basically you can simplify by the 2, and this is the same thing as a 3/5. So because it's the same common factor, I can simplify it. And that would leave me with 3 over minus 6y minus 27. Okay, we can improve a little bit on it, but that's really the hard work almost done. That's really the hard work. So it's a little bit harder than the usual problem. Okay, now can anybody simplify it a little bit more? I will accept this as an answer, of course, but can anybody simplify it a little bit more? It means, can anybody see a common factor in the numerator and the denominator?
3.
3, because if you look at the denominator, watch carefully. I can basically pull out a 3 because 6 is 2 times 3. 27 is 9 times 3. So if I pull out the 3, I will get what's left will be the minus 2y. And 27 is 9 times 3, we will have the minus 9. Now 3 is a common factor. So I will be left with 1 over minus 2y minus 9 and of the problem. Okay. So it will never get harder as far as working with fraction. That's really how hard it is. It will ever get. So if you can go over this problem and kind of make sure you can do it on your own, you will be all right with fractions. Okay. Any questions? I read your question, Sesh. I will look into it. All right. So now we move on to math questions 1.7. Any questions? Please make sure you understand. Please make sure you ask me a question and you bug me. Okay. So we're gonna now look at 1.7, section 1.7, and the question is 5F. All right, we do that. So number 5. Okay. All right, very good. We're gonna do. Let me start by doing an easier one, and then I will do 5F. I forgot what I've assigned. Okay, I'll do C and F, unless you have any other questions. So FC is the following. We have the function. So we have a function. It takes x to x squared plus 7x plus 1. And the question is, find all values of t such that f of t is 19. Okay, so we're going to do this and we do f. So here, this 19, is it an out? So I have a function, f. It takes input, so this is my function, sorry. You give it an input and it gives you something. And the input changes. So if you give it 1, it will give you a number. You give it 2, it will give you another number. Now the question is, if I want the output to be 19, so that's an output value, what should go inside? Okay, that's really the idea. So how do we do this problem? Quickly. Drew Lambert, can you tell me how to do it? Drew, are you with me?
Yeah, I'm here.
Yeah. So
I honestly don't know.
What?
I don't know. I sorry.
That's okay. I want you to do the homework though. Please do the homework. I cannot, there's no way out we're gonna learn if you don't do the homework. All right, that's okay. I'll pick another one. Don't worry about not being able to answer. I don't really care. I forget in half an hour who I ask, so don't worry. I'll pick another one. Isabel, are you comfortable?
Yeah.
Okay, go for it. Tell me.
So wouldn't you make that x a t cubed
Yeah.
plus 7t plus 1 equals 19?
Exactly. So we're gonna, basically we're asking what should be the input? That's really what the problem is. What should I put here? What should I put here? So that the output will be 19. So we're gonna set this equal 19 and solve 40. Okay, so that's really what the question is about. What is it? What is it we have to put here so that I have an output of 19? So we have to solve this equation. All right, how do we solve it? Remember, what did I tell you we should do first?
Subtract 19 for both sides?
Yeah, so we have to make it equal to 0. Crucial. To do that, we subtract 19. equal to 0. All right, and that will give me minus 18 equal to 0. Okay, Isabel, stay with me. What do you do after that?
And you have to find two factors that when added together equal 7, but when multiplied equal negative 18. And
now we have to factor. It means we look, yeah, you're right, absolutely. You look for two numbers. When you multiply them, you get minus 18. And when you add them, you get the 7. All right?
you get negative 2 and 9.
Yeah, that's the natural number, negative 2 and 9. So it's a t plus 9, t minus 2. So here you do basically trial and error. And because I sometimes do mistakes, every time I factor, I distribute again, or I FOIL again to make sure I'm getting the right one. T times t, t squared, minus 2t, plus 9t, plus 7t, minus 18, which is absolutely correct. Now, I'm looking for a t so that this product is 0. So the only way this can, go ahead.
You set both of those to 0, and then you get t equals negative 9, and or t equals positive 2.
Absolutely correct. End of the problem. Any questions? Now, graphically, what this problem means. Graphically is the following. If I sit down here and sketch this function, it means, what does it mean sketch? I start making a table. That's really what sketching is. I take different value of the input. For every value, I find the output. And I start connecting dots. That's really what sketching the graph is. So if you do that, and very soon you guys will be able to sketch this very easily, you will get something like that. Still a parabola. Okay? I think something like that. And the question here, so that's the graph, find all the values such that the output is 19. So basically here, they have the output value here. And the question is, those 2 points on the graph, this is 19. The question is, they are finding for the input. They are finding for the input. That's really what's going on. And according to our answer, this had to be the minus 9. And this has to be the 2. So the question is that we gave you the output. What is the input? It means what is the number here? So that the resulting point will be on the graph. Okay. Yeah, now I'll take F, I guess. That's the question. Number F. And here we are. We have a function g. So if that's the following. You take an input x, and the output is x squared minus 3x plus 3. Okay. And the question is, now this book likes to give you different name for the variable just to make you comfortable with them. Find all values of w such that the function take this to 1. Okay. All right. So again, I have a rule. Takes an input. You give it an input. The input changes, of course. To every input you give it, it has an output, which is given by this formula. As the input change, your output here is going to change. Another question is, find all the values of g of w equal to 1. What equation I need to set up to solve this problem? Anybody wants to tell me before I pick one? So which equation I need to set up to solve this problem? Matt, since you asked me this question, what do you think the equation should be?
Would it be w divided by w squared minus 3w plus 3 equals 1?
Absolutely correct. So the question is, what should I put here for w so it will give me this whole thing will spit up a 1 for us? All right, what's bothering you here? What's bothering you? What's make the problem a little bit hard? So what do you think I'm going to do that? Anybody?
Don't you subtract the 1?
Yeah, but I still have a denominator to deal with. So what do you think would be better to do first?
You multiply each side by w squared minus 3w
Yes,
plus.
we're going to multiply. What's the benefit of doing this? So we will not take the 1 away first. First, I want to somehow not having to deal with a denominator. Now, of course, I cannot just throw it away. I'm going to multiply each side by this denominator. Okay, so we're going to do that. So if I multiply this by, so I'm going to multiply this by this denominator. And 1 times this denominator. Before I take away the 1, I really have to deal with this denominator a little bit. And then I will have w over that. The benefit is those two will simplify. And I will have w equal, now if I multiply this out, this is a 1, so nothing is going to happen, minus 3w plus 3. So multiplying by both sides by this denominator, the benefit of this is actually helping me to have a simple problem.
Chloe
Question?
Forge, is it?
What? I can't hear you.
By snap code.
Okay, all right. So this is going to give me this equation. Now, is this equation easy to solve? What do you think? And how do you do it?
Would you set it to 0?
Right, always, always. We said, how can I set this equal to 0? One side has to be totally 0 because I have this w squared. How can I make one side totally 0? What do you want me to do?
Will you then subtract the w?
I subtract the w.
Right.
One side has to be only 0 and I move everything. So it's easier to make this side to be 0 because I have only one term in here. So if I take the w away from here, I'm going to get a 0. And this would give me w squared minus 3w plus 3 minus w. Okay. And this will end up with 0 equal minus 4w plus 3. Okay, or if you want, I can switch them around. So I keep the same thing, but I put the 0 to the right so it will look nicer. There is nothing deep. Okay, so let us repeat the process here. I had a denominator to deal with. I try basically to get rid of it by multiplying both by this denominator. Doing this, I don't have a denominator anymore. Then I will have w equal this expression. I want to make one side 0. I subtract w. This way I make one side 0. At this stage, we go back to the original problem and we factor. Okay. So we factor equal to 0. And what are the factors here? Are they easy? We need two numbers. When you multiply them, we get 3. And when you add them, you get 4. Okay, two numbers, when you multiply them, we get 3. There are only 2, which is the 1 and the 3. So this is going to be, and because I have a minus, this is going to be minus, minus. And then this would give me, said equal to 0, will give me the w equal to 1. W equal to 3. Okay. Now to check our answer, so we're going to check our answer. To check our answer, what do we do?
We could plug in the w's in for like the so like 1 to the w's.
Right. So to check my answer, I go back and I because I'm looking for all the W that make the output 1. So I plug 1 into the expression of the function. I say, okay, it's for this value. Am I getting 1? So for W equal to 1, I'm going to compute G of 1. And what's G of 1? The function is x over x squared minus 3x plus 3. If I plug in 1, I will have 1 over 1 minus 3 plus 3. Minus 3 plus 3 cancel, I get 1. So 1 is a correct value. Now, is 3 a correct value? I plug in 3. I get 3 over 3 squared minus 3 times 3 plus 3. Plus 9 minus 9 cancel. I will have 3 over 3, which is equal to 1. Okay. All right, so we look at the last one, and which is I guess. Yeah. And then we move on. Any question? You guys are very quiet. Please ask questions. Okay, so let's look at I read it and you guys will have to think about it. Tell me how you do it. So I was, what is I? Oh, did I assign I? Okay. So I didn't know that I assigned I, but I don't think it's very hard. So x squared plus 5x plus 1. And the question is, find all values of h such that equal to 7. All right. What should be my starting point? Peyton, do you have any idea? I want you all to look at it. Tell me your starting point.
We could plug in h for x and then set it equal to 7.
Absolutely correct. Absolutely correct. 7 is main output value. So it means 2. Stay with me, Peyton. And I don't care whether you answer correct or not. Please, as I told you, I forget who I asked. So don't worry about that. How would you do it? How would you do it? What's bothering you?
The square root probably.
Absolutely.
Or no, the 2 first, right?
Repeat, I think you said right, but repeat what you said.
Either the subtract the 2 or deal with the square root.
What do you think it's easier should we do first? Everyone, what should we do first?
The 2?
Absolutely, because I'm going to isolate the square root and that will be easier to work with. Okay, so isolate, we need to isolate the square root. To do that, subtract 2 from both sides. Now I will isolate and problem will become much easier. So this will give me the square root of this equal 7. I'm going to take away 2 from both sides. If I take 2, I will get 5. All right, very good. Peyton, stay with me. What would you do then? Every one of you should be thinking. What would you do then? Now I have to deal with the square root. How shall I deal with it?
Are you asking me?
Can't you
Yeah, that's okay. Go ahead. Anybody?
Sorry.
Peyton. Peyton.
Square it?
Both sides. Square both sides. Now square both sides. And it's going to give me this squared equal 5 squared. Okay. Now, as you realize, we're back to an easier problem. This is the square root. If you square it, by definition of the square root, because the square root is in the number, when you square it, you get what's inside. So that's equal. 5 squared is 25. So a hard problem now turned into something that we actually are familiar with. And now again, because I have h squared, I have to make one side totally 0. So I subtract 25. And then this would give me minus 24. And now the magic way is the factoring. All right, what are the factors you think? So, I mean, two numbers, when you multiply them, you get 24. And when you add them, you get 5. What should they be? Can you just put them down on chat? 24 and 8, what should they be? Danielle Carlo, what should be the number? You have to stay with me, all of you. Two numbers, when we multiply them, we get 24. When we add them, we get a 5. Okay, 8 and 3, because it makes sense. There are other numbers, like 24, you have 4 times 6, but of course 4 times 6, when you add them, you won't get 5. And then you go through 3, 8. Those more likely to give me a 5. So 8, and I copy your student, your classmate, 8 and 3. So it's h minus and h plus that. Okay. And now we're done. I'll double check. H squared minus 3h plus 8h minus 24. So now each one of them is 0, equal to 0. The first one will give me h equal minus 8, and this will give me h equal to 3. End of the problem. All right. Please make sure, do the homework. Please do the practice problem. They are absolutely crucial for your learning. Okay. Now I know one of your classmates asked me a private questions. You stay with me at the end of the hour and I will work it out for you. All right. Okay, so today we are going to keep working with function. It actually is going to be easier because it's not a lot of algebra, but the algebra is so crucial. So we're going to keep working with function basically till the end of the semester. Before I go on, do you have any questions about that? Very good. So we're going to start section 1.8, I guess, and 1.8, 1.9, which are basically, so I'm going to start with 1.9, and if I have time, I'll talk about 1.8, but I want to make sure we get through 1.9. So, 1.8, 1.9. Okay, before I start the section, I need to remind you some notation because they are crucial. So let us recall basically. I know a lot of you know this stuff, but I have to remind you. Recall. The symbol, this one, means less or equal. Okay. So we say 2 less or equal to 4. So a lot of students sometimes confuse the symbol. So this one is the less or equal, and this one is greater or equal. Or equal. So we can write 4 greater or equal to 2. Okay. Now interval notation. Interval notation. Okay. Right. So suppose I want to describe the following point. So I have a number line, that's a line, and somehow I need to describe to you, I'm going to tell you everything less than 2. So I want to describe this collection of points, everything less than 2. We can describe it in words, or we can use the idea of interval notation. So let's see what I mean. So the following interval notation, minus infinity, 2. Closed at 2. This represents, what does this mean? It means all values of x. So this notation represents all values of x that has the properties that x is less or equal to 2. So I'm using a number, but I could have used a symbol, but I don't want to use a symbol. So this interval notation means every number less or equal to 2. Okay, now another notation. Suppose I want to describe everything larger than 2. This interval. So the notation we use is 2 plus infinity, or sometimes just you don't have to put plus. This represents all values of x such that x is larger or equal to 2. So if you want to tell me every x bigger or equal to 2, you can use this interval notation. You tell me everything less or equal to 3, you can use interval notation. Now, suppose you want to tell me everything between 2 and 4. So you want to describe this interval for me. Everything between 2 and 4. So what's the interval notation for it? Close at 2 and 4. This notation, it means that all values of x, everything that has the following property. All values of x that has the following property. X is larger than 2 and x less than 4. Okay. Now, this x bigger than 2 and x less than 4, we write this in one notation. So instead of breaking it up, this could be rewritten. So all values of x such that instead of writing x bigger than 2 and x less than 2, we write this in the same notation and we write it as follows. And this is where a lot of you will eventually, sometimes, a lot of time I shouldn't get this wrong. We write it as x less than 4 and x bigger than 2. So be very careful how we write it. X between 2 and 4, be very careful with how those work. Okay, so this piece here, it means x bigger than 2 or 2 less or equal to x, and this piece right here reflects that x is less or equal to 4. Okay, so those are the interval notation that you will see. I use numbers, but whether I use 2, 3, 4, a half, it doesn't really matter. So finally, we use, sometimes you'll see this notation. This represents all values of x. It means anything, 1, 1/2, square root of 2, you name it, all values of numbers. So it means everything on the number line. So these are the interval notation that we may encounter. And we'll try to use them so you will be comfortable with them. There. So now, as I said, today's section I think is fairly simple. It's increasing and decreasing functions. So I will write the definition and then we're gonna work with it. So let f of t be a function. It means you have a rule. The minute you hear function, that's what should you come up to your mind. But the minute you hear function, it means you have a rule that you give it an input and this input changes, it will give you an output. So here f of t is a function. It means t is the input and this function will give you a certain output. So let f of t be a function. We say that f is increasing on an interval AB. So now we know what this means. That's my interval. If whenever the values of t, means the input values increases, it means when the input change, it means when those input gets larger, the output values increase. Very simple definition. Not the definition in the book. I'm trying to find the basic possible definition. And we say that f decreases if whenever those values, the input increase, then the output decrease. Okay, so let us graphically see what it means. Okay. I'm going to slide down a little bit. If you need it more, let me know. So what does it mean increase? Suppose f of t is a function. So I'm going to graph it. Let us always remember that the input always are here. on the horizontal axis, and the output are here. Okay, and if I tell you the function is increasing, means when the input increase, the output increases as well. So let me call this, for example, 1. I meant -1, 0, 1, 2, and that's it. So I'm gonna take, this is my interval, okay, from here to here. So that's my interval. That's a 0, that's a half, and so on. And so what does it mean increasing? Suppose at 1, that's the value that the function takes. Let us say 2 at 1. What value does the function take? If it's increasing, it means if you increase the input, the output gets larger. It means at 3/2, the function should take a value right here. That's what increasing means. At 2, the function should actually be even higher. That's increasing. At 0, the function should be right there. At -1, the function should go like this. So increasing means as your input increase, so we move to the right, the output values are going to get larger and larger. So the graph is basically gonna rise like that. So if f is increasing, then the graph of f rises as we go from left to right. Rises as we move from left to right. That's an increasing function. Now, what does it mean to be decreasing? Decreasing means that when the input increase, so suppose this is my function defined between -1 and 2, and I just gonna pick some values here. -1 and 3, and suppose I pick 2. Okay, so what does it mean decrease? It means as the input gets larger, the output gets smaller. So suppose the input is here. Okay, for 1, the function takes the value 2. For 2, the function should take a value larger than 2 or less than 2, if it's decreasing. Suppose f of 1 is 2. The value at 2 is going to be more than 2 or less than 2. Quickly. Aiden? So the function is decreasing. It means when the input gets larger, the output gets smaller. So if I give it 2 at 1, what's the output at 2? It's going to be more than 2 or less than 2. Quickly. Sorry. Are you with me?
Did you ask me? It sounded like
Aiden,
you
I
said
think Aiden Campbell, yeah?
Oh, sorry, I was muted. I said if it's decreasing, it's going to be less than 2.
Less than 2. So this function is going to be like that. At 3, it's going to keep going. At 0, it's going to be here. At 1, it's going to be here. So the graph is actually going to fall. Okay, so f decreasing, it means the graph of f falls. Falls as we move from left to right. Left to right. Okay, so increase as the input increases, because the input changes, the output go up. Input decrease, input increase, the output decreases. Okay, that's increasing and decreasing. Now, there is also the idea that sometimes the function remains constant on an interval. So let's see that. We say that f, that a function f of t, for example, is constant on an interval a, b, if f takes the same value for every, if f takes the same value for every value t in the interval. Okay, so we say that the f is constant if the function doesn't change at all. So in this case, how the graph would look like. So suppose this is -1 and this is 2. If the function is constant, what does it mean? How the graph would look like? Now think about it. It means the output is the same. So suppose at 1, the function took the value 5. At 0, it's going to take 5. That's constant. At 1, it's going to take 5. At 2, it's going to take 5. It means the function, the graph, is going to be an absolutely horizontal line. That's a constant function. Okay. All right. So let us take a bunch of examples, some word example and some graphical example. So suppose I take a simple word example. Okay, let me take a simple example. All right, I have a hot cup of coffee in front of me right now. It's morning. A hot cup of coffee is put on a table. Let f be the function that is assigned to each time t, the temperature of the coffee t minutes after we put the coffee on the table. And the temperature is measured in Fahrenheit. So what is my function? What's my function doing? So I have this hot cup of coffee, and I have the rule that is assigned to each time, whatever the time is, this function would tell me the temperature of the cup. Okay. Question number 1. Interpret f of 5 equal 85. And give unit to 5 and 85. So this is a function, that's a rule. You give it the time, space out the temperature. I want you to interpret A.
After 5 minutes, the coffee is 85 degrees.
Right. 5 is the input. 5 is the time. 85 is the temperature. It means 5 minutes after the cup was put on the table, its temperature is 85 degrees Fahrenheit. Okay. By now, my coffee is probably 60 degrees Fahrenheit. All right. Question number 2, again, it's simple. Is the function increasing or decreasing? Is the function increasing or decreasing? Okay, if I want to sketch the graph of this function, if I want to sketch the graph, what should go on the horizontal axis? Olivia? If I want to sketch the graph, I'm not giving you value, but I tell you if I want to sketch the graph, what will go on the horizontal axis? So here, you give it time, it gives you temperature. What should go on the horizontal axis? And what should go on the vertical axis?
The horizontal would be the time, so the minute, and the vertical would be the temperature.
Yeah, time, always the input. Temperature. All right? And now, is the function increasing or decreasing? It means as time moves, is the temperature gonna increase or decrease? Olivia, keep going.
The temperature will decrease.
Absolutely, because time is moving here. Let us say initially it was 100. I don't know what was the temperature. As time increases, that's the input, the temperature changes, but the output is going to go down and down and down and down. So the function is definitely going to decrease because as time, the coffee is going to get colder, so the temperature is decreasing. So the function is decreasing. Because as time, with time, the temperature will go down. Okay, another simple example along the same lines before we think about those problems graphically. Okay, and this always to make it over and over about function. So we have a factory and it produces laptop. And the daily cost changes with the number of laptop produced. It makes sense. How much the company is gonna, it costs the company to produce them is changes with the number of laptop produced. Let f be the function that is assigned to the number n of laptop produced, the cost to produce those n laptop. Interpret f of 1000 equal 5000. So question here, what's the input? What's your output? What kind of assignment is f doing? Okay. Anybody likes to speak up, or shall I pick one? Okay, I pick one. Nicholas Boutrion, are you with me?
Yeah.
Yeah, go ahead.
Wouldn't the 1000 be the laptops that were produced that day?
So 1000 represent the number, so that's the input, exactly. And what the 5000 would form?
The cost charge, right?
Absolutely, don't be afraid. So what's the input here? Don't be afraid, guys. I told you I forget who I ask. It doesn't stay in my mind. What's the input here?
The 1000, right?
That's for this particular problem. You're right. But in general, for the whole picture.
They would be a 5000.
No, you don't understand my question. The input is the number of laptop produced. That's what I meant. Okay, produced.
Mm-hmm.
And the output is the cost to produce them. Okay, that's the picture in general. Now, in this particular scenario, if the number is 1000, the output is 5000. Okay, if it's so, interpret this. We interpret it means that if 1000 laptops are produced, the daily cost is $5,000. So this is just for this particular number. Now, make a graph of f. Is the function increasing or decreasing? You stay with me, Nicholas? If I want to sketch the graph, again, what should go on the horizontal axis?
Horizontal, wouldn't that be a...
Always the input.
Oh,
What's the input here? What's the function doing?
it would be the number of laptops, so that would be 1000.
But 1000 is not the only number, the only input. It's the input as the input changes.
So wouldn't it be like 1 to 1000?
Maybe, but maybe the company produced 2000. I really don't know. So the input changed. So that's the number of laptop produced. So you have to pick, and we have to keep in mind that the input is not, even though I ask you to interpret it for a particular value, just to make sure you understand the problem, but the input changes. Probably the company one day produced 1000, another day is going to produce 2000. So the input changes, and that's crucial for understanding function. It's not only 1000, the input is actually changing. I don't know. So one day the company decide, okay, I'm going to make half of the factory work. Another day I'm going to take the whole factory. I mean, so the input change here. So the number of laptop produced, and this is the cost. So how many laptop produced? I really don't know, but it's changing. But the question is, as the number produced, what happened to the cost? Is it going to increase or decrease? Very simple. I'm still with me, Nick?
Yeah.
What do you think?
Wouldn't the cost increase?
The cost increase. So it starts somewhere as time go by, and so as more laptops are produced a day, definitely their cost is going to be increasing. Okay. So you ask yourself as the input, but we should understand the input is not only 1,000. The input changes. The input represent how many they produce. So the company is going to sit down and say, okay, if I produce 1,000, that's my cost. If I produce 2,000, that's my cost. If I produce 500, it is my cost. So the input change. And as the input change, the output change with it. But intuitively, the more you produce, the cost is actually going to get higher. Okay, so crucial that the input is not only 1,000, it's really changing. When the company is studying its production level, you say, okay, how much if I produce 500? How much 1,000? How much 2,000? How much 1,500? So they try to pick for every number of laptop produced, what is their cost. So that's increasing. Now we're going to work in a more graphical way. So now I'm going to sketch a graph simply, and I'm going to ask you questions about the graph. So the graph is just, in a graph it in an arbitrary way. So this is my graph. So I graph it in front of you. So if you guys are copying, you will have the time to do that. So this is the graph. And I'm going to pick, and here I have an output for every input. So this is a 1, this is a 2, and so on. And my function looks like that. And it's gonna go like this. And it's gonna go like that. And then it's taking off. That's my graph. I'm gonna call this 1. This is a 2. This is a 0. And that's the graph of f. So this is x, and this is f of x. Okay. Question is, determine the interval. Determine the interval over which f is increasing. So the question now, this is the graph, and the question is determine the interval over which f is increasing. Okay, I'll give you a minute or two to think about it, and then we're gonna get together and answer the question. Okay, anybody is ready? Anybody is ready to answer?
Yeah, so when it's increasing, it's negative infinity to -1. And then
Increasing, yeah, you're absolutely correct. It's increasing everywhere the graph rises. Because up to here, when my input increase, as you guys realize, that's the input, my output getting larger and larger. So up to here, it's increasing. And then we write this down. Okay, keep going. Where else?
Also, it increases at 2 to infinity.
It increases everywhere here. It's increasing. Okay, so determine the interval over which f is increasing. Okay, f is increasing. I'm going to write that in two ways. One in word and then one using interval notation. So before interval notation, we say f increasing for all values of x, for all values of x, such that x is less or equal to -1 or x larger or equal to 2. So that's really in words, okay? Now, if I use interval notation, we say, or you can say the following. F is increasing on the interval -infinity -1 and on the interval 2 plus infinity. All right, so you can write it either using words or using interval notation. Question number 2. F is decreasing. So on which interval is f decreasing? Can you ask yourself, when is the graph rising? Means the output. When is the output rising? Okay, let me pick one because I think now should be easy. Taylor? Taylor, are you with me?
Yes.
Yeah. Can you answer the question? When is f decreasing?
The -1.
From -1 all the way to where? On which interval? On which interval? So it decreases, it's an interval, because -1 is a point. That's the value at -1. So it decreases, it means as the input change. So you need an interval to have different values of the input. So if you look at the graph between -1 and 1, between -1 and 1, as the input changes from here to here, what's happening to the output? The values are getting smaller and smaller and smaller and smaller and smaller. So it's decreasing between -1 and 1. Okay, so it decreases on an interval. It doesn't decrease at a point. At -1, that's its value. It decreases, it means you have to let the input change. So as the input go from -1 to 1, the output was here, it's getting less and less and less and less and less. So it's decreasing. So f is decreasing. We can write it two ways, with and without. I would like you to make sure we can get both f decreasing for all values of x, such that x is between -1 and 1. Now the way we write this is like this. X is bigger than -1 and less than 1. That's how we write it. Or you can say f decreasing on the interval -1, 1. Either way, describe it. So f does not decrease at a point. You have to let the input change, and it increases on an interval, not at a point. Part C, f is constant. So on which interval f doesn't change value? Means it remains the same. So whatever the input is, the output is the same. Peyton, can you stay with me? Peyton Sale.
Yeah.
Yeah, go ahead. Did I ask you before? I don't know. I told you I forget. All right, what's the answer? When is it constant?
Wait, can you repeat the question for me? I got confused.
That's okay. Determine the interval over which the function is constant, does not change value.
1 to 2.
1 to 2. Okay, so it has to be an interval. Okay, so f is constant for all values of x. Such that x is less than 2, bigger than 1, or on the interval 1, 2. Both mean the exact same thing. All right? Question? Okay, let's do another one very quickly. And this time, I hope all of you should be able to answer me. So I'm going to sketch the graph. I sketch it in front so you guys can copy it. So my graph will look like this. That's -2, -1, 0, 1, 2, 3, 4. Okay, and I'm going to make it look like that. And then I want it to go up. And then I want it to go down. And then constant. Sorry. Straight. So this is my function. That's my graph. Okay, I'm just. And the question is the same. On which interval f is increasing? Okay. I would like to answer this question. Okay, let me pick somebody. Drew, would you like to answer it?
Yeah, the function increases -1 to 2.
Okay, so how do you want me to write it?
You'll write with a
Without
bracket. If I'm doing interval notation.
Interval notation.
A bracket, -1, and then another 2 and a bracket closed.
Without interval notation.
So like writing it like in Word,
Yeah.
or like
For values of x that has the following property. Describe them. It means I want you to tell me x between -1 and 2, but in symbols.
Oh, so you're saying like -1 is x is greater than -1 but less than 2.
Right. So how can I write this symbolically in one sentence if you want?
-1 less than or equal to x.
Less than, absolutely.
And then less than or equal to 2.
Yeah, be very careful. -1 less or equal to x. Or x bigger than -1, but that's how we write it in one word. Okay, f decreasing quickly.
Did you want me to continue? Is that?
Yeah, if you want to, I don't care.
Oh,
Go ahead. So, but let me here on the graph make sure. F increasing. Yeah, decreasing.
Okay. -infinity to -1. And then 2 to 3.
2 to 3. Okay. You can close it or open it. I actually don't really, it doesn't really matter. Okay. Now, in Word, f is decreasing for all values of x, such that. Okay. Stay with me.
-infinity is greater than or less than or equal to.
You don't have to write -infinity now. X.
Oh, okay.
You just write x less or equal to -1. You don't have to write -infinity because everything less. So we never write -infinity. We actually write everything less. Keep going. Or x is where? Because we have two places. Or
Yeah,
X
X is
between
2 and 3.
Okay. Finally, F constant. That's the picture. So it's decreasing everything. It's decreasing and decreasing. Constant means it does not change value. It means the output is the same. So where is the output the same? It's still the same student.
It's 3 to infinity.
3 to infinity. So constant on the interval 3 to infinity, or all values of X, such that X is larger, bigger or equal to 3. Okay, that's notation, the interval notation and inward, interval notation and inward. So we are very comfortable with that. Okay, so increasing and decreasing function, they are really actually, it's very simple concept. It's not really hard. The main thing that I want you to understand that the input changes. The input is not one value. The input change, and the input change, your output is actually changing. Now, the last thing is I'm going to talk about is the following idea, that a different way of writing a function. So let me take the following scenario. Suppose I'm going to go back to one of the problem that I did. So we said, so this is, I think, 1.8. I forgot the name of the section. Okay, the idea is the following. So far, when we described the function, we wrote the following. I said, okay, let f be the function. That is signed, that's what I wrote verbatim, that is signed to each time t, the temperature of the cup of coffee So I'm writing this whole thing t minutes after we put it on the table. Or if you don't, after 10 minutes after whatever, we put it on the table. The table, okay? Now, there is another way to rewrite this. So we can rewrite that, rewrite this idea the following. Okay, we can rewrite by writing the following. We say that instead of telling you that the temperature F is assigned to time, you give it time. So as time changes, of course, the temperature changes, give you the temperature. Another way we write this is the following. We say that the temperature of the cup of coffee, what I'm rewriting it, is, that's the key word, is a function of the time t, is a function of the time t after we put the coffee on the table. Okay, I'm gonna read this and analyze it. A lot of time, instead of telling you in a very clear way what F does, telling you that F is assigned to time the temperature, a lot of time people don't describe the function in these details. However, they write it in the following way. They tell you the temperature is a function of the time. So when they write it this way, what they mean is what comes after a function of is usually the input. That's the input. What comes before it, this should be the output. So we always said that the output is a function of the input, meaning as the input changes, the output, the temperature is going to change. So instead of telling you F is assigned to time temperature, we say the temperature is a function of the time, which makes sense. The temperature basically is changing with the time. As the time changes, the temperature changes. Okay, so a lot of time, instead of writing this whole thing, which is the book is emphasizing, we can rewrite in the following way. So what comes after a function is the input. What comes before it is the output. So let us say I tell you the following. The cost to produce laptop is a function, so that's the problem I took, of the number of laptop produced. Okay, the cost to produce is a function of the number of laptop produced. What do you understand by this? And what's the input and what's the output? So the cost is a function of the number. Means as the number of laptop produced, the cost will change with them. So in this scenario, what comes a function of, this will be your input. What comes before what's a function of, this will be the output. So the cost is a function of the number of laptop. It means as the number of laptop changes, so the number of laptop changes, that's on the horizontal, the cost is going to change with them. So instead of telling you, let F be the function that is assigned to the number of laptop, the cost, they say the cost is a function of the number of laptop. So that's a different way of writing the function that you will encounter a lot. So we have really definitely to understand it. So what comes after a function of is your input, and comes before it is the output. So I can say the population is a function of the year. It means as the year changes, the population is changing. The year will be the input, the population will be the output. That's really how it works. So this is what comes after is the input, what comes before it is the output. Right. Any questions? You guys have your Moodle homework. How is it coming? Hello? How's the Moodle coming?
Is that due later?